C almost looks right, but we're actually missing a comma here, which I don't know if that was maybe just because you can't see the screen close enough. But the answer here would be D, because we have our return type, we have one function name, and then our parameters look good. So number 3 is D. All right, what is the output of this program? So go ahead and try running that. So this is a tracing problem. Do you guys normally have those on your exams?
Yeah, we have one, but I think they failed the entire pointer section.
Oh, gotcha. Okay. Well, then this is a good introduction to getting that down. Can you actually sit up a little bit? But yeah, so we're going to just trace through this problem how you would on an exam, ideally. So with any tracing problem, you want to keep track of all your variables. So we'll have int x equals 357, x equals 357, and we have y equals 109. And this is happening in main. So then we go to our swap function. And then right away, we pass in the address of y and the address of x. Are you with me so far?
Yeah.
And do you know why I keep them separate? Like why I create 2 different sections for them? It's because the variables that exist in main don't exist in the swap function, and vice versa. There's only going to be local variables there, right? So we pass in the address of y and x. Hey, what's up, man?
This is a study session?
Yeah, it is a study session.
Why do we need 2 people in here?
That's a great question. But yeah.
There's one at 4, but.
So we pass in the address of y and the address of x. And so we go on over to our swap function, and let's take a look at what's happening there. So we have.
Can I just ask, like, what is the concept we're going over?
We're just hitting a bunch of different topics.
Okay.
It's sort of like questions and then going through them and then teaching anything that's not there. All right, so we have temp, and it doesn't have a value yet. And then we say temp is equal to dereferenced y. And here's where it gets a little tricky. So we passed in the address of y and the address of x into there. But then in the swap function, we called them x and y. So it's almost like reverse there, right? So we say temp is equal to dereferenced y, which is our second parameter, which is going to take us to the address of x. So temp now has 357. Does that make sense? You sure?
Yeah, it's just a lot.
What do you mean by temp?
So in our swap function, we have temp there. But here.
What does swap function do? It just swaps the address of the 2 variables?
No, you don't swap the addresses. You're swapping the values. But we have, let me start over here. So we have int, we have x equal to ampersand y, and y equal to ampersand x. So when we pass those, the address of y and x in main, this is how they're being received. So now the x in swap has this address, and the y in swap has this address. Good? So then we say temp is equal to dereferenced y, which we know the y here in swap has the address of x. So when we say dereference, what does that mean?
It means you're bringing the address with it.
Kind of. What does it mean to dereference?
Dereference would be to take away
Not quite, no.
Address of it.
So to dereference means to go to the address of. So we say, let's dereference y. Y is holding the address of x. So that means we're going to go to x, get the value here, 357. And in this case, we set it equal to temp. Boom. Are you with me? Then we say dereferenced x, so the address of y. So we're going to be looking over here, is equal to dereferenced y, which is going to be the address of x. So now we're looking at here, and we're actually changing this value to 109. Do you guys see that? I can go through that one more time if that wasn't clear. And what's your name?
Paul.
Paul? Okay, so we got Paul, Stephen, and then remind me of your name again? Jonathan. Paul, Stephen, Jonathan. Cool. Right now we're just going through a swap function, but it's sort of like a tricky one. It's just not a basic swap function. But yeah, on that line we have dereferenced x. So we are looking at x. It's saying go to the address of y. Okay, so I actually messed that up there. So it's saying go to the address of y. So we're looking right here and say set it equal to dereferenced y, which is the address of x. So 357. So this value back in main is actually being affected. And then we say dereferenced y. So the address that y is holding is x. So we go to x and we set it equal to temp. And this is where the swap function is a little tricky and sort of useless because we're setting x equal to 357, which it already is. And so when we print this out, we'll get 357, 357. Any questions, comments, or concerns with that? No? Yes? Maybe? Yeah, you guys could trace through this problem if you had to? Okay, cool. And then Paul, take a notebook out for me. This is an interactive review guide right here. Right, so true or false? This is a valid struct definition. What do we think? Before saying it out loud, come to the conclusion in your own head, and then we'll discuss. No, you're good. Okay, cool. So yeah, as Jonathan mentioned, this is false. Why do you think it's false?
Because it's a type def, you need the name of the struct after the bracket before the semicolon.
Yeah, so that's exactly right. If we wanted this to be a valid struct, we would put whatever name we wanted right there, and we'd be good to go. You guys are good with that? All right, cool. Number 6, what's going to happen if you try to write to a file that does not exist using the W mode? What's up? None of the above? Okay. Paul, what do we think? The program will not compile?
I think it's A.
So yeah, once again, Jonathan is on the money. If you're writing to a file that doesn't exist using the write mode, the compiler will create one for you. If you try to read from a file that doesn't exist using the R mode, the fopen function will return null. And then if you try to run that program using your null file pointer, then your program will probably crash, but it will compile. So the answer there is A. All right, so here we got another tracing problem. So just go through that on your own, and then we'll run through it together. I can tell you right now, there's no way any of you will do it in your head. If you do, I'll be amazed and very impressed, but chances are you won't. AKA, write stuff down, trace through your variables. Try to treat this as sort of an exam, because that's what's going to give you the best value in terms of showing up. If you just show up and like kind of listen the whole time, it's not really going to help you out too much, you know? How's it going?
Hi.
What's your name?
Greg.
Greg, cool. Got got a lot of one-syllable names. John, Greg, Paul, Steve.
There's me.
Hmm?
There's me with like 3 or 4. I can't remember.
Yeah, but you could call it John, even if you don't go by it.
I go by both.
Okay. So then, Greg, like I was mentioning to them, this is not a problem that you will probably be able to do in your head. So your best bet would just to take out a piece of paper and try to trace along with the variables. And we have a couple problems like this, so it'll probably be in your best benefit to do that. Wish we had like some light background music, you know?
Always put on the jazz station.
Yeah, true. All right, what do we think? Anything here that's tripping you up? Yeah, because you're trying to do it in your head.
Yeah, I mean calculator.
Still in your head for the most part. So remember, your first index is going to be equal to 12. This part is just saying the current index you're on is going to be equal to the previous index plus a, and we know a is doubling each time, so that's just something you have to take into account. Hey, how's it going, guys? What's up, Bailon? Rocking the flannel, I like it. I said rocking the flannel, I like it. And then, what's your name? Chris?
Yeah.
Gotcha, cool. What's up?
You're holding the paper.
Oh, it's a little piece of tape. Nothing too interesting.
Did you get a fortune cookie?
No. Okay. So yeah, if you guys want to take your notebooks out, we're just going through this tracing problem right now, and we'll have some later on as well. So we'll run through this one in a second. Is the Pan Express good?
Oh, I love it. They have their honey walnut shrimp is so good.
That sounds pretty good. I'm just glad they didn't open up another sandwich place.
Yeah.
I mean, I guess they did, but
I mean, they closed down the Domino's down there. There used to be one.
yeah. I mean, we don't need 3 Domino's on campus.
No. I just can't wait for them to open up a Steak and Shake down there next.
That's going to be good.
Except for they don't take gift cards.
So I'll give you guys 1 more minute for this one. And even if you don't finish, that's okay, just as long as you're sort of doing it the right way, then you'll be good. Chris, what's your major?
I'm mechanical engineering.
Nice, we got a couple mechies in here. What about you, Greg?
Same, mechanical.
Got 3, 4, wow. Jonathan, what are you again?
Physics.
Physics, and then Ilana's computer science. Yeah? Okay, cool. All right, cool. So let's run through this. You leave all the chicken for last? What's wrong with you, man?
What?
You leave all the chicken for last?
It's the better part of the meal.
I guess. Okay, cool. So like with any tracing problem, we want to keep track of all of our variables. So we have I, we have an array of size 5. We have A, B, and C. And then A is 9, and then B and C are 1. So the first thing we do is we initialize array sub 0 to 12. Then we set I equal to 1. 1 is less than 5. So then we say array sub 1, so we're looking at this one, is equal to array sub I minus b. Well, I is 1 and b is 1, so that's just going to be array sub 0. So it's equal to 12 plus a, and a at this point is 9. So we are at 21. For those of you, did you guys get this part so far? Okay, so then let's keep going. Then we say a plus equals a, which is saying what?
A plus A.
Yeah, it's saying a is equal to a plus a, essentially doubling it. So then a is now 18. And then we say b equals to c, and that's really just trying to trip you up, because b and c, those values are not changing, and they're both equal to the same thing. So then we go again. I is now 2. And so we say array sub 2, right here, is equal to array sub 2 minus b, which is 2 minus 1, which is 21. 21 plus a at this point is 18, so this is going to be 39. Then we say a plus equals a, and that gives us 36. Did you guys make it this far? What tripped you up?
21.
Mm-hmm.
Isn't that going to be, oh, never mind.
Got you. All right. So then we've doubled it. Did we double it? We just added 18. So yeah, we just doubled it. So then we keep going. B equals C. Again, that's a line of code that's not doing anything. So I is now at 3. And at this point, you should see the pattern, right? So we're looking at this index. We're going to add the previous one and the current A. So that's going to be 75. And then we double this, iterate again, and then array sub 4 is equal to 75 plus 72, which is 147. Anybody get that? You got it? Just now, though.
I did the math wrong, but yeah.
Okay, got you. Anybody else? Cool. Alrighty. Any questions, comments, or concerns with this code? None of you guys could do this if you saw it? Cool. All right, so now we're going to do a 2D array tracing problem there. So I'll give you guys a couple minutes to work on that. What's up? Do I have a pen? Come on, man. This is a good pen. You better give that back to me.
No problem.
You don't have one? I can give you a sheet of paper. I'm going to be really annoying about it because I want you guys to be involved in doing this. Because, oh, I like Tame Impala a lot, actually. But, yeah, I got you. I was already on my way. I think this should work. Hey, how's it going?
Not the second forward, or that first forward. Is it I equals 0, or is that J equals 0?
In the first one? Or the second one? The second one is saying j equals 0. What's up? We're just going through review problems right now. Sorry, Parth, you're going to be doing a lot of walking. That's why you make the big bucks. That's why you make the big bucks. Cool, so I'll give you guys 2 more minutes for this. All right, cool. Let's go through it. If I move the board, do you think we can just get it in the same shot? Am I blocking anything from here? No, we're good. Okay, so let's take a look at it. So just like any tracing problem, what's the first thing we want to start doing? Keep track of all the variables, exactly. So we have a 2D array. How many rows and how many columns? What does that mean, that 2, 4 there? Which one's rows and which one's columns? Exactly, yeah. So it goes RC. So we have 2 rows, 4 columns. That's kind of small. Oh, the stains. So 1, 2, 3. Then we have I, J, and T. So I, J, and T is equal to 15. And then we say for I equals 0, 0 is less than 2, so we enter the for loop. And then we say nums I3, so 0, 3. That's going to take us over here, is equal to T, which is 15. Then we say T plus equals 2. And then we enter a J loop, and we say nums I. So I is going to be 0, but I won't be changing, so we know we're only going to be hitting the first row, is equal to T. So then at this point, we say 0, 0 is equal to T. And then this is where you have to be careful. Since we don't have curly braces for this for loop, the whole body of the for loop is just this one line. Do you guys see that? That T minus equals 3 is not a part of the for loop. Did that trip any of you guys up? Cool. But yeah, so we're going to iterate that nums ij equals 3, equals T 3 times. Yeah, 3 times. We'll see. So we have 0j, so that's 0, 0 is equal to 15. Then j bumps up to 1, so 0, then 1. So 0, 1 is equal to t, which is 17. 0, 2 is equal to t, which is 17. And then at this point, we have 3. And then 3 is not less than 3, so then we give me 1 second. That might be a mistake. So we're going j equals 0, j equals 1, j equals 2. All right, let's keep going. I might have messed up there in writing the problem, but we'll see. T minus equals 3, so then we change this to 14. So now at this point, we iterate the I loop again. So now we're looking at I equals 1. And we say, you good?
Should be.
So yeah, so now we're looking at nums 0, nums, oh, okay, that's where I messed up. So the 0, 3 originally, the 15 should have gone here. You guys should have caught that. So then we say nums I3 is equal to t, and so we're looking at 1, 3 now, right? Which is 14. Then we say t plus equals 2. So now we're looking at 16. And then for j equals 0, so now j is back to 0. Nums 1, 0 is equal to t. So now we're going to be looking at the whole second row, because we know that this second for loop is just hitting the rows, is equal to t. And t is equal to 16. And so then at that point, we know these are going to be filled with 16. Any questions, comments, or concerns? I know that was not very smooth and cohesive, but I can go through it real quick again if you guys want me to. Yeah? Okay, perfect. Okay. Yeah, I lied. I'm going to put the board back. It's really annoying to keep checking what's on there. I think that's what it was. It was the board. That's what threw me off a little bit. So we have nums 2, 4 set up just how we did before. Then we have I, j, and t. T is set to 15. Nothing else has values yet. So I is equal to 0. 0 is less than 2, so we enter the for loop. So now we're saying nums 0, 3. So 0, 3 is equal to t, and t is 15 right there. Everybody with me? Then we keep going. We say t plus equals 2. So now t is 17. And then we go into our j loop. J is now equal to 0. And so as soon as we enter this j loop, we know the I value is not changing, right? So we're going to be staying within the same row. And looking at the loop, we also know it's going to iterate 3 times. So it's going to be nums 0, 0 is equal to t. So 0, 0 is equal to t. Then j increments. And so now num 0, 0, 1 is equal to t. Num 0, 2 is equal to t. And then once we get to 3, we know 3 is not less than 3. So we stop looping there. And are you guys all familiar with the for loop? And since it has no curly braces, it's just going to take the next statement. Yes? No? I saw a couple maybes. So anything that has a body, something like an if, a while, a for, anything that could have these curly braces under it, if you don't have the curly braces under it, the compiler will just assume that the body will be the next statement. So that's why if you have while, print whatever, and then a print here, and if you have no curly braces, only this printf will be a part of the while loop. This one won't be. If you wanted both, you'd have to use the curly braces. Cool, so let's keep going. Then we say t minus equals 3, so that gives us 14. And then we say, this is not statistics, this is intro. Have fun. So then we say, we start the second iteration of the I loop. So I is now equal to 1. And we say nums 1, 3 equals t. So that's going to be this spot here, right? 1, 3. And t is 14. So we have 14 here. And then and then we increment by 2 for t, so we're at 16 now. And then once again, we enter the j loop, so this is back to 0, and we say nums 1, 0 is equal to t. So t is 16, this is 1, 0. Then j goes up. 1, 1 is equal to t. 1, 2 is equal to t. And then once we get to 3, we know 3 is not less than 3. So then we minus equals by 3, and so we're left with 13 there for t. And then we print out the results. So we should get 17, 0, 3 is 15, and then 1, 3 is 14. Did anybody get that? That one was a little tricky, clearly. Any questions, comments, or concerns with this one?
A little bit. So after, like it did increment from +2 in the first one to 17.
Mm-hmm.
How come it didn't like increment anymore after, but it would fill the row, the rest of the row for 17? 19.
So you mean on the first iteration of the I loop? So we were at I equals 0, and so then we said 0, 3 is equal to t, which at the time was 15, right? Then we incremented t by 2 to make it 17. And then are you asking why we didn't keep incrementing by 2? What do you mean?
Yeah, but why didn't it increment afterwards?
Well, it did, but we minus equaled it by 3, and then we added 2 to it again on the second iteration.
Okay.
Does that answer your question?
Yeah, I was for why it didn't like when it filled the rest of the row. Like I can.
In the j loop?
Yeah, or for the I loop, like for nums, like I next for 3.
Mm-hmm.
I can see how it's like, or it goes up to like 15 and sets it for the first one.
Yeah.
For 0, 3.
Right.
That one.
Is it the j loop that's like throwing you off a little bit?
I'm not even like onto like the J loop, but I guess I thought it would like go for like 19 and 21 and then fill the rest of it. Like it would still stay on that loop.
Well, keep in mind, this is this nums I3 equals t. This is just a single line, and this for loop is only running twice. So we're just going to pass by it like a regular line of code. Only when we get to the j loop is when we're like consequently doing a bunch of them in a row. But yeah, that I loop runs twice, so that's why we're incrementing t twice. We do it once from 15 to 17, and once from 14 to 16. Cool. Any other questions about this program? You guys could do this if you saw it on an exam. It's really just about labeling your variables well, and then just trying to be very careful and precise when you're doing this. You're basically like trying to turn into the compiler. Alrighty, let's move on. All right. Which of these is a valid way to insert a string into a character array? I'll give you guys a second to think about it, and then we'll discuss. Oop. And then I'll actually have the answers on here after the review, so you don't have to take pictures unless you really want to. All right, raise your hand for A, for B, for C, and for D. Okay, so let's go through them. String cat, B, word, we have a couple interesting things going on here. So string cat, the first parameter has to be a variable string, because you can't concatenate something onto a string literal. Do you guys know what I mean by that? So this string literal B, we have it typed out within double quotes, and it's a string literal because we can't change the value of this at all. It's just there, right? It's like trying to change the value of a 7. That's not within a variable. It's just a 7. You can't. So this would actually cause your program to crash just because the first parameter of string cat has to be a variable string, something like word, right? Assuming word is a character array of length 20.
So you'd have to do word B.
And you'd be using string copy, not string cat there, which, you know, if we look at this one, we are now using the correct function, but it's the same issue of the parameters being in the wrong order. We can't have the string literal as the first option. And if we look at this one, B is actually the correct answer. Because if we go through it index by index, character by character, null terminator at the end, everything here looks good. And the other two are syntactically wrong. Any questions, comments, concerns with that?
Then for C, it will be okay if it has to be like.
Yeah, exactly. If you switch them around, then C would be perfect. Cool. So then, oh, I like this one. So this is another tracing problem. Go ahead and try that one out. This one's a little tricky. You got to be pretty precise with it. But I have faith. Whoop. This is a fun one, right, guys? Remind me of your name again? Michael? Okay. Michael, how's this looking for you? How do you feel about it? You gotta write it down. You can do your best to do these in your head, but it's just a lot cleaner if you write it all out. Oh yeah, this one's pretty interesting. I like this one. I made it myself, you know. No big deal. Jonathan, you got it?
I don't think so.
Who knows? Who knows?
I think I do, but I'm pretty sure it's wrong.
The backslash T's are just tabs, by the way.
Tabs? Oh, okay.
Yeah.
I've never seen backslash T.
Oh, okay. Yeah, it's not going to affect your calculations at all.
Oh, okay.
Whenever I do these tracing problems too, you know I have the printf z equals k equals blah, blah, blah. I'm always tempted in the variable list to just like completely switch them around. But I think that's a little too cruel. I'll give you guys one more minute. You just got to be very precise, very careful. All right, cool. So what did we get for the answers? Jonathan, what'd you get?
You got a 1, 1, 27.
Any, Ilan? Oof, close. Any other answers? All right, let's go through it. So as always, let's get our variables in order. So we have z equals 27. We have pointer k is equal to the address of z. And then we have b is equal to dereferenced k. So what is b equal to? Someone just shout it out. The value of k. So 27. Did this trip anybody up, those first initializations? It can be a little tricky. Just you have to remember when you're declaring your pointer, you use the asterisk, and then any time afterwards that you use an asterisk with that pointer, you're saying dereference this. In other words, go to the address of. Does that make sense? Are you guys with that? So Chris, what does it mean to dereference something?
So you're going to go with, dereferencing, you're going to go to the address for its value?
Yeah, exactly. So that's why when we say dereference k, we're saying go to the address of z, look at its value, and in this case, we set that value equal to b. All right, so then the next line, we say k is now equal to the address of b, and we say z is equal to dereferenced k, so we know the value of z is going to change, and it's equal to dereferenced k. So if we dereference k, we go to the address of b, look at 27, and it's 27 times 3, which is 81. So then we go to the next line. Then we say z, so we know that value is going to change, is equal to z divided by dereferenced k. So if we look at k, it's holding the address of b. So we get that 27, and we say 81 divided by 27, which is 3. And then we keep going. Then we say dereferenced k, so the address of b. So we go to b over here. Dereferenced k is divide equals to z. So 27 divided by 3 is 9. Are you guys with me? Did I lose anyone on that?
So if you use the asterisk with k, it changes b. But if you don't use the asterisk, it changes k itself.
Well, say that one more time.
So, like in z equals asterisk k times 3, what if you didn't use the asterisk for k?
Well, then it wouldn't make sense because the address of b is going to be some hex value, and it's going to be like pretty big, times 3. So it's just going to give us like a big garbage value that we don't really care about. So you're never really going to do arithmetic with the address of something. You're going to dereference that address and do the math with whatever's at that address. But yeah, while I was going through that, did I lose anybody? Can I get some nods, some shakes? I did lose you, okay. I'm just going to go through it again because I feel like you guys are not very chatty today. What's going on? Engineering and computer science, we love talking. That's all we do. So yeah, with that first line of initialization, I want somebody else to walk me through it. Hands up, come on. Who's feeling courageous on this Saturday afternoon? Jonathan, I'm going to pick on you. Come on. Come on up. So do the first line.
First line?
Mm-hmm.
So that's k equals address of b.
The first line of code.
Oh,
starting with int z equals 27. Yeah, awesome. So we know b is equal to 27 because it says b is equal to dereferenced k. So dereferencing k, we go to the address of z, we get the 27, we put it here. Everyone could do that, right? All right, next line we say k is now equal to the address of b. And then we say z is equal to dereferenced k. So as soon as we see that equal sign, z equals, we know we're going to be changing the value of z. And then we say dereferenced k, so we go to the address of b, 27 times 3, which is 81. So then we keep going. Z is divide equals to dereferenced k. So now we're saying is equal to z divided by dereferenced k. So dereferenced k, go to the address of b, get that 27. So is equal to 3, because 81 divided by 27 is 3. So are you guys still with me? Any confusion there? Cool. So then we say dereferenced k, so we go to the address of b. So now we know we're changing the value of b. Is equal to, is divide equal to z, which is 3. So we're saying 27, or we're saying b is equal to 27 divided by 3, which is 9. And then we change k to say the address of z now. So then when we print out z, dereferenced k, which is now holding the address of z, so print out another 3. And then b, we get 339. So Ilon, you were pretty close. You're just 1 power of 3 off. Any questions, comments, or concern? Oh, what's up to the guys in the back? How's it going? Cool. Let's keep moving. Anybody going to the game today? Nobody? Dang. Yeah, I'm not going either. Yeah, absolutely. Which segues perfectly into our next one. Write a program that places the string anxiety into a character array just large enough for it, then prints out the string in reverse order. Does that sound like something you guys could do? And if you're a teacher at this point, covered malloc, try to use malloc when you're writing this up. So I'll give you guys a couple minutes to work on this. And so guys in the back, just like I've told everybody else, sitting there and listening might be good for you, but you're going to get the most value out of this by actually working through these problems along with us and then discussing what went wrong or what went right for you. So yeah, feel free to take something out and try to work on it. Or don't, and that's fine too. What's up? Oh, okay. Mm-hmm. Oh, you're not in this class? Oh, gotcha. No, you're good. Cool. Well, then sit back and enjoy the show. You still need your notebook out, though. Not really. Again, it's up to you. No pressure. You don't need to take it out. But it's up to you. Feel free. But again, your choice.
Is this review on the SARC website?
Mm-hmm. It's on the Study Union website. And then I'll post the answers for that after the review.
And is the one, the other?
It's up to them.
Today is a different one?
Yeah. Everybody's got their own review. Mine's the best. I said mine's the best. Maybe. Just a little bit. How many of your teachers covered malloc or are going to have that on the final? Just quick raise of hands. Just Zumlansky then? Nobody else? Okay, cool. Okay, cool. Then just declare it statically if you want. How's it coming, Michael? How's it coming along? Well, we know you don't have to use malloc. We know we can just declare a character array statically, right? I think the tricky part would just be printing it in reverse order. Cool. So is anybody done or almost done? Just so I can see how you did. Perfect. Yeah, this looks good.
Awesome.
So,
I actually did it right.
Anybody else? You finished up? No? Alon, what you got? Nothing? All right. All right, cool. So let's go through it. So we know anxiety is a very serious issue, rampant in our society. Now, we know anxiety has 7 characters, and so we want a character array of size what? Yeah, so we want size 8, because we want it to be long enough for the actual word plus 1, and that plus 1 is taking into account what? Exactly, yeah, the null terminator. Null sentinel, null value, there's a bunch of different terms for it. So char word 8, and we could say is equal to anxiety, and that would be the simplest way to do it. You could also do string copy. You could also do it how we saw it in the previous question, character by character, but that would take forever. And then we want to print this out backwards. So any ideas on doing that? Okay. So 4, and then what'd you say? I equals 6. 0. I minus minus. Cool. So this almost looks good. What is my concern here? Yeah, we want to start at 7 because if we are looking at this array of, well, if we have it backwards, then the last character will be the null terminator. So I guess it doesn't matter if we print out the null terminator or not. So 6 or 7 won't make a difference. It's up to you. We'll stick with 7 just so we're printing out the whole thing. But yeah, and then just printf %c, and then word sub I. And we'll put a little space there. Is everybody good with this? And we say less than or equals 0 because we know we want to print out the 0th index, right? All right, cool. Any questions, comments, or concerns with this code? No? Looks good? All right. So fill in the code so that you put the string stress into a file called finals.txt. So go ahead and give that a shot. I already gave you sort of the skeleton for the file IO syntax, so it shouldn't be too bad. And I've already got the string for you right here. Cool. Anybody stuck? The syntax for file I/O can be a little tricky sometimes, but it's not too bad. Just really a matter of remembering it. Cool. So what do I put inside of our fopen? Parentheses?
Not parentheses, the quotation marks.
Yeah. So we want finals.txt. Cool. So are we good here? Someone not named Jonathan. What's the next parameter? Ilan, what do we put? You said R? Okay, cool. What do we put here? Yeah, so OFP. Yeah, so then we'll put %s. Yeah, cool. So an easy way to remember the syntax for printf, for fprintf and fscanf is that they look exactly the same for printf and scanf. So imagine you're writing a printf or a scanf function, and then to make it pertinent to files, you just change the name of it, and then you give it the file pointer. And then the last thing we do is close it. So then what goes in here? OFP, yeah. So does this code look good to everybody now? What's wrong with it?
Should be W naught.
Exactly, yeah. R is for writing, R is for reading, W is for writing.
Should it also not be in quotations?
Yes, we do want the mode in double quotes. Cool. So, any questions, comments, or concerns with this code? You guys look really excited. Happy to be here. None? You guys are good with file I/O? It's really just the only thing with file I/O that's hard to remember is this fopen. You have to remember to capture its return value by placing it into the file pointer. And you have to remember the first parameter is the name of the file, and the second is in the mode, both in individual double quotes.
Do you have to put the W there to use the right?
What do you mean?
Why you put the W again? Can you explain that?
So we put this W here to indicate to fopen that we're going to be writing to this function. This is the mode that it's in. We could also have it in R, which is to read, A, which is to append, and then you have W plus and R plus, which each do different things, but are probably not relevant to the scope of your class. Okay, so we have another tracing problem, so go ahead and go for it. Alon, you done? Cool. Paul, you agree with that? Jonathan, what'd you get? Cool, cool, cool. Greg, what'd you get?
Lost what's happening at the M equals Z.
We'll go through it. Steven, how's it going?
I got 30.
Okay. Chris, how about you? Okay. And Michael? Cool. So for those of you that said 28, you are correct. So let's go through it. Alrighty. And so whenever I see other functions too, I create different boxes because we know the variables that exist within different functions only exist within those functions. So this is main, and that is Z. Okay, so we have R equals 3, M equals 7, and then we say M is going to equal, so I'm just going to go ahead and write that equal sign because I know that the value of M is going to change as a result of this function. And our function is called Z, and we're passing in R, which is 3, and then M minus R, which is 7 minus 3, which is 4. So then the M in here is equal to 3, and the R in here is equal to 4. Everybody with me so far? So then we have Z is equal to 0, and we have an I there with no value. I is equal to 0, and then we have while I is less than R, which is 4, Z plus equals M plus R. So Z is going to, so 0 is less than 4, so we enter the loop. Then we say Z is equal to Z plus M plus R. So M plus R at this point is 7. Then we iterate again. I is now 1. And then we say M plus R, 14. We go again. 21, because 3 plus 4. It's 3 plus 4, 7, 4 times.
Oh, I missed that.
What's up?
What do you know R is for?
Right here? Because when we pass it into the function, we pass in 3 for the first parameter, and then we pass in 7 minus 3 for the second parameter, which is 4. Because see how we pass it into the function on the second line of code? Those are the two numbers that we pass in, 3 and 4. So then in this loop, we're just going to be adding those numbers up R times. So it's going to run 4 times, and it's going to add the number 7 4 times, and that's going to leave us with 28. Not too bad, right? Some of you guys got 30. How did you land on 30?
I missed the M, I'm sorry.
Oh, okay.
So when it iterates to, like, for the next one for 3, how come it's, like, it feels like equal, or I equals, like, or less than or equals to 3, or R, stop at 2?
Well, here we're saying essentially I is equal to 0, I is less than 4, I plus plus. So we know we're going to run 4 times, 0, 1, 2, 3.
It stops at 4? How come on I equals 4?
Because
Oh, pass the parameter. That's that one?
yeah, because R within the Z function is 4. So we're starting at 0 and going until we're no longer less than 4.
Oh, okay. I was just like reading R in like as like this initial one.
Yeah, that's why you got to be careful with it and keep your variables from different functions separate. Any questions, comments, or concerns with this code? All good? What's up?
What is Z?
Z is the name of the function, and it's also a variable name that we used within the function.
I thought you can't have the same names
What do you mean, a variable within an array?
Like you can't have a variable in an array with the same name.
Well, an array name is a variable name, so those would be two different variable names. But this is a function name, and you're not calling it as a function here, so you're good to go. You explicitly say int z equals 0. So all good here? Yes, yes, some nods. Come on, people. All right. What number will string length return for this string? Think about it in your head, and we'll discuss in a second. Okay, cool. What's it going to return? Just say it out loud. 5, 6. Raise your hand for 5. Proudly. Come on, high up so I can see it. Raise your hand for 5. We got 1. Raise your hand for 6. Okay, so string length will count the characters 1, 2, 3, 4, 5 until it sees the null terminator, and then it's like, we're done. So it doesn't count the null terminator, so the answer would be 5. Alrighty, 15. I'll give you guys a minute for this one. Cool. Who says A? Who says B? Who says C? Who says D? Whoop. No, I got it. And who says E? All right, cool. So A we know is not correct because this is for comparisons and we're not comparing anything here. B, we have this little 0 initialization shortcut. So this would be a valid way to initialize all of it to 0. This would work if the I was a 0, but it's an I, so it won't work. And since we know it's not C, it can't be D either, which leaves us as B for the answer. This is a shortcut that will only work for 0, by the way. You can't initialize it to some other number.
So if you put 1 in there, it only initializes the first space as 1?
Yeah, it'll give you the first index as 1, and then the rest of them will be zeros.
Or wouldn't they all be garbage numbers?
All zeros. All good with this one? All right. So this one is a little long. We'll make it work. That's pretty small, actually. Let's see how we can do this. We'll just skip this one. We'll come back to it. Oh, okay, this one's fun. All right, so based off of this code that's going to be using our O struct, you need to figure out what the contents of the actual struct are. But yeah, and then assume that any arrays that are being used in the struct are of length 10. And then sometimes they'll give out coffee cards, and I don't drink coffee. There's no coffee card this year. Well, anyways, normally I really like this problem, and I'll do it that if anybody gets it 100% right, I'll give them the coffee card, but there's nothing for me to give out this time because I'm not giving out the shirt. Yeah, this is my shirt. I only get one, so. Oh. And then also, if at any point during the session you guys could fill these out, that would be greatly appreciated. And then if you could pass one down to him. Thank you. This is a pretty nice bag. Yeah, so if anybody gets the answer 100% right, you can get this bag. And so if you think you have the correct answer, just come on up here and I'll let you know. It's first come, first serve though. So if somebody gets it before you and you still get it right, there's only one bag, so.
We're just figuring out the initialization of the variables. What it was?
You're just filling these gaps in. You get one try. Let me see. No. Nope.
Oh, I know it. Yeah, I got it.
So just gotta really look at the code here for a second. See what matches with what. I'll give you guys a couple minutes for this one. Come on, guys, look at this sweet bag. You weren't that close. If you want to try again.
Wasn't that close?
If you want to try again, you can try again.
Oh, wasn't that close?
No. No. No.
No?
Mm-mm. Come on, people. I said, come on, people.
Stuff that definitely goes on the right side, right? Please.
Maybe. Oh, you were saying you just wanted me to check the left side?
No, I mean, like, I wasn't sure, like, with the right side, was some of them, if there was stuff.
Could be. Who knows? I know. Anybody still working on it? You guys must not really want this bag. I like this year's theme, the whole flamingo. It's pretty cute. Damn it. Ooh. Of course. All right, Greg, last shot. No. Michael?
No.
Okay. All right, cool. So let's sort of go through this code logically. So we have our O struct called P. We have some float Y. And the first thing we do is we string copy a whole string into a single index of an array. So we know if this were just a regular old string, we would have it p.shoe, right? But since we're looking at an index of this array and putting an entire string into it, we know that we must be looking at a 2D character array. If it was just a regular character array, it would be there would be no sub-zero there. So this is going to be, yeah, that's hat. So then this is going to be char, shoe, 10, 10.
Could you also do char asterisk shoe 10?
Yeah. But yeah, does that make sense with everybody here? We see here that if we're just into one single index putting a whole string, we have to be looking at a 2D array, not just a regular old array. Does that make sense? All right. Then we see this %c is the address of a single index. So if a single index, if the address of a single index is a character, we know that p hat has to be a string, right? So then p hat is just a regular character array. And so then the other ones are pretty easy. Then %d p.x, we know that that's just going to be what? Just an integer, yeah. And then the last one, we said flow is equal to ampersand y. Y is a float. So then this has to be what? A float pointer, yeah.
Now in the scanf, I thought you didn't have to have the ampersand with the string.
You don't,
Then why is it there?
because this is for a character.
Isn't character still a string?
No, a character is a character. Cool. Any questions, comments, or concerns with this code? No. Good try for those of you that did try. Why is it 10? Just because I said any array lengths will be of length 10. Because it's a 2D array. Because here we're saying put this entire string over here, p.shoe0. So if we're putting it into an individual index, if an individual index is a string, that tells us that we're looking at an array of strings, otherwise known as a 2D array, a 2D character array. Does that make sense?
So that's saying like 0, 0 is C, 0, 1 is O, and so on. Is that how that works?
Say that one more time.
If we're looking at the array and we're print it out,
Mm-hmm.
we could do printf shoe 0 and then 0 would be C.
We could say that one.
So I'm trying to figure out.
If we wanted to print it, we could put it in a for loop that runs 10 times.
Right.
And we could just say p.shoe I. and then printf %s. Does that make sense? Okay, let me draw it out. It's a little hard to visualize. I had one. Oh, I dropped it, right? Where'd my marker go? Oh, it's over here. How'd you get it over here, Paul? Come on. My one marker. Okay, so if we have shu 1010 declared like that, we have one, two, three, 4, 5, 6, 7, 8. Okay, let's start over. This is ugly. So we have, let's say 4, 4 for the sake of conciseness. 1, 2, 3, 1, 2, 3. Are you guys, so this is the 2D array that we're looking at, right? In here, there's words cat, dog, roof, pal, I don't know. And so we know with a regular array, when we declare something like, if we declare something like char word 3, we know we're declaring this array of size 3, right? And we're also declaring a pointer to it. Are you guys familiar with that? Yes, no? Okay, so then this is going to take me on a tangent. So when you declare an array like that, you're declaring the actual memory, and you're declaring a pointer to the first index in that memory box. If you guys haven't seen that before, that's what's happening when you declare arrays. And that's why in scanf, you don't need an ampersand for strings, because the name of the array is already a pointer. The pointer is called word, and it's pointing to this sub-0 index. That's why when you say something like word sub1 is equal to C, we know we're going to put a C right there, right? But how it's actually doing that is it's looking at word, which again is pointing to the first index. You guys are with me? So it's pointing to the first index, and it's saying, OK, move it up 1. So we move it up 1, and now we're looking at array sub 1, and we put the C there. Because just looking at word itself, if you cover it up, if it's just word, then that's the address of the first index. So with a 2D array, you're actually working with, and this one is called shu. You're actually looking at a pointer of an array of pointers. And I'll draw it like this just so it's a little more concise. So this is essentially what it looks like when you have a 2D array declared, because now you have a pointer that points to your array of pointers that points to the actual memory boxes. And so that's why when we say scanf p.shu0, we're saying, OK, use this address, which is the address on the top row, and place the word in this row. I don't know if I just made things more complicated as opposed to simpler. Greg, how's that for answering your question? Any questions, comments, or concerns with this concept of pointers and arrays and 2D arrays? All good? Cool, cool, cool. Alrighty. So using the signature below, write a function that compares two integers and sets the smaller one equal to 0 and returns. If the numbers are equal, return right away. I called it deathmatch. So yeah, give that a shot. What's that?
X equals y.
If x equals y?
Double.
Double equal signs? Cool. So if x equals y,
Braces. All right. Bring that. X and y are similar.
if the numbers are equal, we can just return right away. So we don't need to print out anything. And so you guys see how I mentioned earlier, we don't have any curly braces under this if statement, so it's just going to, yeah, it's just going to assume that we are just using this return as part of the body of the if statement. All right. Chris, what do we put next?
If x is greater than or equal to y. Next line. Set y equals 0.
Mm-hmm. And then we return out of that case. And then, the last one would be if y is greater than x equals 0, and then we return, right? So you guys are good with this one? All of you are cool with this? This is correct code. This looks great.
You don't have to use second.
What's up? Well, yeah, let's assume we've already written the second if.
Use the same thing, just reverse.
Exactly, yeah. But let's say the second if is there. All this code is good. All this code is correct. I am happy and content with this code. What's up? One part is definitely missing. Any ideas on what that might be? Mm-mm. Yeah, exactly. We're passing in addresses here. So here we're comparing addresses. Here we're comparing addresses, but we don't want to be comparing the addresses. We want to be comparing the values of those addresses, the values at those addresses. So then to do that, we dereference. So we say if dereferenced x is equal to dereferenced y, we return, because then we know those values are even. If dereferenced x is greater than dereferenced y, then dereferenced y equals 0. And then in the last case, it would be if dereferenced y is greater than dereferenced x, then dereferenced x equals 0. All good? Any questions or comments with this code? All good? Yeah, we wouldn't need to because this is a void function, so we have no return type. Cool. All right. Why did I do these long programs?
Data structures and trees in here?
No, nothing on trees. You guys are learning what kind of trees?
And what subject did Hani in this? What was the kind of trees?
Because trees are like a huge overarching topic with a lot under it.
I think he's having it on the exam. If and else if statement.
I wouldn't call that a tree though.
It was
All right, so we'll also skip this one just because like I don't know what I was thinking there. All right, 20. True or false, this function takes in a person struct pointer and successfully prints out its contents. This answer should come to you within 30 seconds. I heard a no. All right, raise your hand for true. How about false? How about no voting? Cool. So it's a void function. It's called print person, and assuming this was type def correctly, it takes in a person struct pointer. So far, everything about the statement is true. Then we say %s user dot name, and that's when we know this is false, because when we're working with struct pointers, we don't use the dot operator, we use what? We use the arrow, yeah. And this is very, it's pretty easy to remember because a pointer sort of is like an arrow. It has a direction that you're looking at. So this would need to be arrows all around, and then it would be true. So then 20 is false. Have any of you guys done recursion in your classes? I threw it in here because sometimes the teachers like to do that. Yeah, you guys are in the same class.
It's like a little bit.
Okay. Do you know if it's going to be on the final?
Yeah, probably a little bit. I don't know.
What about you guys? Any of your classes done recursion? Yeah? Okay, so then we can do this problem together just because I don't expect you guys to know how to do it otherwise. So if you're given code like this with just a bunch of variables, your best bet is to plug in your own values and try to see what's actually happening there. Because it's asking you what is this recursive function doing. So let's take a look at it. And first off, what is recursion?
It's when a function references itself.
Yeah, a function that calls itself. So we have int y, and let's say we pass in a 4. So we have our base case. Our base case is just the if statement that is eventually going to break us out of this recursive cycle. So we check, is 4 less than or equal to 1? It is not, so we want to return x. So return 4 times the result of another function call, so times y, x minus 1, which is 3. So now we have another function call here, and I'm going to keep these grouped. So then we have int y3. We check is 3 is less than or equal to 1. It's not, so then we return 3 times, and then the result of another function call, 3 minus 1. And so then this one is grouped, and so then we get a little lower. So int y, this time 2. And we check is 2 less than or equal to 1. It's not, so then we return 2 times 1. And then at this point, and I'll label these 1, 2, 3. And then in the last one, we say int y1. And this time we actually do return 1 because 1 is less than or equal to 1. And so now these function calls can start tracing back to the original one. So we return, this is a 1, kind of looks like a 2. Bang. So we return a 1 here because that was the result of this function call, right? So then this is a 2. We return this 2 over to this function call because that's what it ended up being. So then 2 times 3 is 6. And then we return this 6 over to the y3. And then the final answer is 24. And so at this point, maybe you saw it, maybe you didn't, but what is this function doing? So this function took in a 4 and returned a 24, right? And it did this by saying 4 times 6, 6 which was 3 times 2, and then 2 which was 2 times 1. So in this case, it was 1 times 2 times 3 times 4, otherwise known as a factorial function. So that's what this function is doing. So for those of you where recursion might show up on your exam, it's really just about keeping track of your function calls and going lower and lower until you do hit that base case. For those of you that do not have recursion, this is just an interesting little introduction, I guess. Cool. So 22. How many times will bananas be printed here? How many? 10 times? Okay. Any other answers? Okay. Any other answers? Notice that I is being used for both loops. What's that? Twice? Okay. Okay. So 18 would be the answer if the second loop had a different variable like j. Ilan, what are you thinking? You know, I bought a blue flannel for Black Friday, similar to that one. But instead of white, it's black and blue. It's pretty nice. But yeah, Ilan, what do you think? Infinite? What do you guys think? Why infinite?
Because it keeps on resetting it back to 0.
Yeah, this would be an infinite loop because you get into this loop, then immediately you get into this loop, and then I is going to keep going until it hits this 3, then it'll break out, come back here, and then I will be 3 every single time, and you'll never reach your terminating condition. So yeah, you just gotta take a look at it, and then maybe if you even want to write out a few iterations, that always helps. But yeah, turn yourself into a compiler, be the computer, do your best. How many of you covered malloc and calloc? Quick share of hands. Okay, do you know if malloc is going to be on your exam?
I think you're going to do it pretty easy, just because, like, I think you went over it pretty quick.
Okay, then we can just talk about the syntax of it real quick. So which of these successfully allocates an integer array of size 10? We can just, well, let me see. Okay, perfect. Yeah, we can ignore the callocs. Let's just look at the mallocs for now, since that's really the only thing that's relevant here. Malloc is a function that takes in the number of bytes, and it returns to you memory with that number of bytes. So if we pass in 10 bytes, we're going to get like 2.5 integers, which is not what we want, and it's also not an array of size 10. So we want to call malloc using size of int, which is going to give you 4 bytes, usually. We say size of int instead of just typing a 4, because an integer is not always the same size on all machines. And we also do that just in case in the future the size of an integer maybe changes sizes. So we say size of int times 10, and then that's going to return to you an array of size 10. So the answer for this one would be D.
What does calloc do?
Calloc does the same thing as malloc, except calloc returns everything initialized to 0. So malloc is going to give you an array of size 10 with a bunch of garbage values in it. Calloc would give it to you with a bunch of zeros. So what is this recursive function doing? We'll come back to that if we have a little time, just because we're almost done with this review, and I want to see if you guys have any last-minute questions. Okay, 25. What is the output? So this goes to the very beginning when you were just learning how large data types are. And can anyone tell me what the size of function does?
Returns the size of the number of bytes.
Yeah, number of bytes. So if we have a double array of size 20, what is our output going to be? $160. What do we think? Paul, what you got? No idea? Steven? Chris, come on. Michael? What's up? 21. Greg? 160. Ilan? So this is 160 because a double is 8 bytes. And you can just think of it that it's double the size of an integer, which is 4 bytes, usually. But we're going to assume that this is the regular, or like the most well-known. And so then size of that would be 20 times 8, which is 160.
How you get 20 and the 8?
So the 8 is the size of the double. If we have an array of 20 doubles, each one 8 bytes long, 8 times 20 is 160.
The Sizeof function can't be used for a character array, can it?
Yeah.
And that would just return how would that return?
Well, characters are typically 1 byte, so just...
So just return how many spots array the array has?
Mhm. Yeah. Cool. So then this talks about calc, which you guys aren't familiar with, so I'm going to skip that one, and I'm going to look at the last problem here. Which of the loops run 14 times? Select all that apply. This one takes a little bit. Michael says B. You think D?
So it could be B and D.
Everybody's got their answers? All right, raise your hand for A. Raise your hand for B. Raise your hand for C. Raise your hand for D. And raise your hand for E. Okay, so let's take a look at it. So A, why is this not correct? It's an infinite loop. We have no way of meeting our condition, so we know it can't be A. Let's take a look at B. If we have I starting at 0, and it increments by 2 each time until it's less than or equal to 27, well, let's think about that. It's never going to hit 27, right, because we're only moving in even numbers. So it's going to stop at 28, right, because it's going to get to 26, and it'll keep going. Let's run this real quick. So we'll start at 0, go to 2, keep going, 4, 6, 8, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26.
Then run again.
Yeah, and then at 26, and we're at 13 right now, it'll run one more time, hit 28, and then 28 is not less than or equal to 27, and so that ran 14 times. Yeah, that's why I actually tested this one earlier. Oh, see, it's already there. But if we look at this, we have I equals 0, and then we have the loop that I have as one of the options, and if we run that. It's a little small, but it prints out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because once it gets to 28, it doesn't iterate again. So B is, as we know, now is the answer. But let's take a look at why some of the other ones aren't. So we have while plus plus I is less than 14, this will actually run 13 times because we'll plus plus I right away, and then we'll say while 1 is less than 14, and then at that point we're going from values 1 to 13, which is 13 times instead of 14. And then D looks like it runs 14 times, but the syntax is wrong. These commas should be semicolons. So yeah, that's our last question. Any last minute topics or questions that you guys wanted to cover? You guys are all 100% ready for your finals, feeling good? All right, well, if you guys have no questions, thank you guys for coming. Have a nice day.